Hi class. In this video we'll be talking about transformation. Using transformation we can change aspects of the way that the P5 canvas renders to do things that we wouldn't be able to do otherwise with our graphics. So I'm going to talk a little bit about what transformation is, and then I'll do some examples in P5. Then we'll look at ways that we can use it to animate our memes. So before we get into our project, let's talk about what transformation is. You've probably used transformation before if you've used Photoshop. I'm going to do a quick demonstration using the painting program Krita. I'm just going to create a new file here. If you haven't used Krita before, it's an open source painting application. So I'm just going to draw a quick little drawing. Then I'm immediately going to just do some transformations. So under the layer menu, there's a transform. You can see it has things like rotate, scale, shear. You can also access transformations visually by hitting Command T, selecting a layer. There's different transformations I can do, like I can rotate. I can change the size. I can also do shear, which distorts the image at an angle. These are all things that we haven't been able to do with our code so far. Specifically, rotating is something that we couldn't do using our position or size or color variables. So by doing transformations with our canvas, we'll be able to do things like rotation and scaling and shearing as well. Another thing to notice here is the pivot point. So if I move the pivot point, the rotation happens around that pivot point, so it changes the way the rotation looks. And if I move the pivot point down here, it changes the rotation. It also changes where we scale from and shear from. So we'll look at how that affects our P5 sketch as well. So those are some basic transformations. Let's look at how to actually add that in our code. So I'm going to leave Krita. I'm going to open up GitHub as usual to start. And I'm going to go to Show in Finder and duplicate my project from last time. So I'll make meme version 3-2. Again, you don't need to make two projects. You just need to make one. And you can combine these techniques if you want. I'm just making two projects so I can separate them as I do the demonstration. So I'm going to move MMP 210 over to Sublime and open my folder and go to sketch.js. I'm just going to delete everything here and do some demo. So this is meme version 3-2, transformation plus animation. So let's just start with some examples with transformation. So with transformation, we have translation, rotation, and shear, and scale. So let's just start with a simple drawing. So I'm going to say function setup and create canvas, and then function draw. So I'm going to start with a rectangle. Just draw a rectangle at 0, 0 and 100, 100. So when I go to start my Sublime server and open a new window, go to localhost 8080 and type in my new URL, meme version 3-2. And we can see our rectangle. Let's draw a background real quick so we can see that. Typically our rectangle is going to be drawn right here. That's 0, 0, right? If we have 0x, 0y, that's this corner here. And then 100x, 100y is the width and the height of the rectangle. So if we translate before the rectangle, so I'm going to translate to 200, 200. Now our rectangle moves even though the XY position is still 0, 0. So translate translates the origin of the canvas. So the origin of the canvas is usually 0, 0 up here. But what this does is it takes that origin and it makes 0, 0 right here. So now x is positive in this direction, y is positive in this direction, and then x is actually negative this way, y is negative this way. So now if we had a negative x, we still see our rectangle. And we can also move the translate around using mouse X and mouse Y. So now the 0, 0 is changing and the position of that rectangle changes along with the mouse. This means that we can change the way our sketch works overall. If we have like a lot of shapes, we can move all of the shapes at once just by changing one value. So if I have translate 0, 0, that'll be up here. And let's say I had, a whole bunch of rectangles. So I'm just going to add some rectangles in here real quick. So if I have a whole bunch of rectangles and then I change translate, they all move at the same time because the entire canvas has been shifted over. Translate also works similarly to how fill and stroke work, but it's additive rather than replacing. So it's a little bit different. So I'm going to turn on no stroke for a second. So if I change the fill red and I move it down here and say fill blue, we'll see that the second two rectangles are blue and the first two are red. So this red fill applies to these two rectangles. The blue fill applies to these two rectangles. However, with my translate function here, if I apply a different translate, and I'm going to do a simple one, so I'll do 0 on X and 100 on Y. Now you can see that my first two rectangles are moving over by 100. But my second two rectangles are now moving over and down. So instead of the blue replacing the red, the first translate is actually added to the second translate. So let's visualize that by making our two rectangles the same. So I'll have 0, 0, 100, 100, 0, 0, 100, 100. So the red rectangle moved over by 100 for that first translate 100. Then the second rectangle was already over 100, and then we moved down another 100. So we add them together. There is a way to prevent that from happening using a couple of functions called push and pop. I can push before I do a translate, and I can pop after. So now my first red rectangle has the first translate, X plus 100. My second blue rectangle has the second translate, Y 100. So when I push, I'm adding this new translation to a list of translations. Inside of P5, there's a list of the translations, and that list has 0, 0, X as the origin, and 1 is the scale, and 0 as the rotation. And that's the basic translation. There's some other data in there, but that's just the first one on our list. So when we translate, if we push, we add a new part to the list. Now it's 100, 0, and the scale is 1, rotation is 0. So when we push, we're saying add this to the list. And then when we pop, we're saying remove this from the list. So we cut that out and we go back to here, and then we translate. Push and pop are programming concepts that we probably won't get into this semester, but that's basically a summary of what's happening here. So we can see that in action. If I move push down here, it goes back to how it was before. We have to push and then translate. For this one, I don't have to do that because there's nothing that comes after. But if I wanted to do something else, like translate 200, 200, and then I'll copy the same rectangle here. So now we're getting this one, and then 200 and 200. So if I want to prevent that from happening, then I can add another push. pop. So those are some of the basics using translate. Let's look at scale. So I'm gonna delete most of what I've got here and go back to just a single rectangle. And to illustrate this a bit better, I'm going to translate to the middle of the screen. So I'm going to translate to width divided by 2, height divided by 2. And that's something that you may do pretty often if you want to center 0, 0 in the middle of your screen. So we have our red rectangle, and if we change our scale to 2, now we have it twice as big. And we can also make scale map to a value. If I say mouse X, it's going to be way too big. But if we use a smaller value, so I'll use S for scale and map mouse X from 0 to width, and I'll use a regular scale of 1 to 2, and then scale by S. Now the scale grows at a normal rate. And the scale affects everything from this center point. So if I add another rectangle and put it on the other side of that point, and I'll change the color as well. Notice how the blue rectangle gets larger to the left and the red rectangle gets larger to the right. So the pivot point is where we're translated to when we scale. If I change the position of those rectangles regarding the pivot point, then they'll scale in a different way. So if I move these guys back a bit, now they're scaling farther back. And if I move this red one to the other side, now they're both scaling to the left. So the scale increases around that pivot point. This also works with an ellipse. You can see the ellipse is directly in the center of translate, so it scales right into the middle of the ellipse. If we move the ellipse a little bit off, now it scales outward. We can also make scale go smaller. So if we go past 0, the scale reverses. So we could do the scale from -2 to 2, and we can flip the whole drawing. So the combination of translate, scale, and some of our other functions is what adds up to these different effects. So let's get rid of scale for a moment and look at rotate. If I rotate by 1, you can see that's actually a large rotation. The reason for that is the default measurement for rotation in P5 is pi. So if I put in pi for my rotation, you can see that it rotated exactly half a circle. If I put in pi times 2, then it goes back to normal. I'm going to open up the console for a moment. If I hit pi in here, you can see the value of pi. It's a mathematical constant that's used to measure circles and angles. And so if I want to rotate, I need to convert to pi. If I say mouse X, I'm using really big numbers, I'm going to get a crazy amount of rotation. But I can convert my values to pi. So let's say variable r for rotate is map mouse X from 0 to width. And I'll just map from 0 to pi times 2. And then we'll put in r for our rotation. And we'll see our composition rotate in one full circle. Of course, if I want to rotate more, I could say pi times 3, and then I can rotate more. But the rotation eventually goes back to the beginning, somewhere around here. Our rotation also occurs around that center point. So if we move our ellipse back to the origin, now it doesn't look like the ellipse is rotating at all because it's right in the center and it's a circle. So we don't see that rotation. When we move the ellipse away from that center, then we see the rotation happening. Same with our rectangles. If I put a rectangle at 0, it's going to rotate around that center point. If I move it farther away, it's going to be rotating around the center point still. And if I change my translation so that it's still in the upper left corner, then we'll see the rotation is happening around that upper left corner. Again, where we rotate changes our sketch. So let's go back to the centered version of the sketch. If I move this rotate function below my red rectangle, now my blue shapes are rotating, my red rectangle is staying the same. So my translations or my transformations only affect the shapes that come after them, not the ones that come before them. The last transformation to cover is called shear. Shear is a little bit trickier. When we were looking in the Krita drawing, we could skew or kind of distort the image. And shear is based on moving points of the image away from a point at an angle. So it also uses the pi rotation measurement. I have a couple of web editor examples that kind of illustrate how shear works. So here's shear X. You can see our rectangle, and as I increase the shear value, you can see that these 2 points at the bottom of the rectangle, here and here, they move away from this line at a specific angle. And so that shear value goes up to pi, is half a rotation across the circle. It's also affected by the translation pivot point. So if my shape is farther away, the shear is more dramatic and it moves along that angle on the y-axis. So shear is a bit harder to control, but you can create some interesting effects using it. Here is the same example, except using shear y. So now we're moving away down the y-axis instead of across the x-axis. So we move the 2 points to the right down. So just like our rotation, we can use another rotation variable, mouse x, 0 to width, 0 to pi. We can do pi times 2 again. And instead of rotate, I'm going to shear on the x-axis using that rotate variable. So now you can see the distortion, and then it flips around. So once it flips over half a rotation, it goes back to where it was. And if we change that to shear y, then it happens on the vertical axis. And if we do both at the same time, that's probably going to look kind of crazy, but let's check it out. So we can get some kind of cool effects by using these values. So how can we make some animation for our meme? So I'm going to grab my lizard image. So say variable lizard image, and then preload it, function preload. Lizard image equals load image, lizard.jpg. And so I'll replace my shapes with my lizard. So I'll say image, lizard image, and we'll put it at 0, 0. So notice that the image is drawing from the top left corner, but since we've translated to the middle of the screen, since we've translated to the middle of the canvas, the image appears to be offset. So let's change our image mode to center. Now the image is centered. We can make our canvas a little bit larger if we want to show more of the image. And so now we can animate our image. So let's remember the types of transformation that we have. We have translate, we have scale, rotate, and shear. So let's try scaling the image. So if we do scale 2, the image gets bigger. If we want to animate that, we can create a variable. So let's say variable s equals, let's start at 1. Let's increase the scale. So I'm going to scale at s, and then I'm going to say s plus equals 1. That's going to go way too fast because we're using scale. So let's use a smaller number. We'll use a fraction here, or a decimal, 0.1. Even that's very fast, so we can do 0.01. Okay, and then at a certain point, we probably want to scale back, right? We don't want to scale forever. So we can say if s is greater than, let's say 2, then we can set scale back to 1. Or like we did in the previous video, we can create another variable to track the speed of the scale or the increment of the scale. Let's call this scale speed, and that's 0.01. So then I can replace scale speed, and instead of resetting scale, I can say scale speed times equals -1. So I'm just going to remember that from our previous video. And so now we scale in and scale out. Of course, we have to make sure not to keep going once we get back to 1. So scale is less than 1. So I'll add that condition. So scale, if scale is greater than 2 or scale is less than 1, that will make us go in and out. And maybe we can actually use something a bit smaller so we can reveal the lizard since the image is bigger than the canvas. We can also animate our text. So let's add some text. Say I'm a lizard. And again, we can put this text at 0, 0 because we've already translated to the middle of the screen. Let's change our fill to yellow and our text size to 100 and our text align to center, center. Okay, so we've got I'm a lizard. But if we want the text not to be animated with the scale, we can simply put push before scale and pop after our image. So we have to include the image in there. If we pop before the image, then we'll just be scaling nothing. So we leave the pop after the image. Now we can add another animation for the text. So for this one, let's do something fun with the shear. So we can create another variable. Let's call this text shear, and we'll set it to 0. And then we will shear on the x by the text shear value, and then we can increase the text shear value. So if we do 1 here, it's going to go really fast. Okay, it looks kind of glitchy because remember we're using very small values here for rotation. So if I use 0.01, now we have a more reasonable animation. And because the shear is rotating, I don't actually have to reset it because it just goes in a circle. I could, if I wanted to, at a certain point, stop it and reverse, or I can let it continue to go in a circle. So these are just a couple of different examples of ways that you can use animation along with your translate, scale, rotate, or shear to add to your meme animation. So that's it for this video. I'm going to go ahead and add a link here. So under index.html, I'm just going to add a second link under meme version 3. So this is meme version 3-2. And just another reminder that you only have to do 1 for your assignment. So you don't have to have 2 like I do. These are just 2 different examples. And so for your final assignment, you can feel free to combine whichever of these techniques that you want to create the animated version of your meme. So I'll go to GitHub and just add this. And just make sure I spelled that right. And push to origin. So that's it for this video. Let me know if you have any questions. You can email me or message me on Discord or ask in class.